Well, hi, good morning. Thanks again for joining me here in my shop. I don't want to be left alone with this radio. So I'm going to talk a little bit about the situation here and a couple things I did last night off camera, and then I'm going to repeat them. And what happened? One of my lights just gave out. Hey, we're off to a good start here. There we go. Apologize for that. I just slapped the microphone, so sorry about that. So let's start with the odd behavior of this blue capacitor. So this blue capacitor, here's one here. I have 10 of these or so, and they're low voltage capacitors. They're good for 100 volts. Okay, man, that's a sign of things to come here. They're good for 100 volts, and I thought this is a good position to use one up. These on the label say 9,000. I'm just double checking that. 9,090 picofarads. 9,090. Why not just 9,000? 9,090 picofarads. So 9,000 picofarads is the same as 0.009, which is almost the same as 0.01, which is why I chose to put this kind of capacitor in here. I tested this one. I thought, oh my gosh, I didn't test the capacitor. Maybe these are duds. No, this tested exactly 9,000, or just a hair over 9,000. And this one in the circuit also tested 9,000 using this kind of tester. So I don't think there's any problem with the capacitor. But more than that, oh, and also putting in the shielded wire here, that's kind of like a last-ditch effort. That's all I had in my head. It doesn't make sense to have to redesign the radio. It should be sufficient the way it was originally designed, so you wouldn't expect it, but to help out. But some of these radios are so cheap, I'm not saying this one was, that in fact they were built with hums in them that would be covered up by the program material. My thinking there is, well, that may be true when the radio is brand new. These hums and whatnot are so low that no one would care. But maybe over time, with different things getting old, maybe those things present themselves a little bit stronger, which is why I went ahead and did this. That's a pretty flimsy reason, but also this is a harmless thing to do. Put in a shielded cable to the grid. You see my signal tracer. I came in here last night thinking, oh my god, it could be a humming tube. It could be a tube with some leak between the heater and maybe the heater and the grid. I don't know if these are even cathode tubes. I think they are. Yeah, sure they are. I'm thinking from the diagram. Maybe there's a leak in there and somehow the heater hum is becoming apparent. So to check for that, I got out my signal tracer and began tracing where the hum comes from. We're going to do it again in just a few minutes and see if I get to the same spot. The reason I did that last night was I knew that if it turns out one of the tubes is humming, I'm going to have to search through my tube collection to find a replacement. I've made a nice index of most of my tubes, but they're the ones that are, say, 1940s and newer. 1940s, 1950s tubes. I have all those registered in a spreadsheet. I have them all carefully arranged. You can see some of it down there in those buckets. All the tubes down here are all on a spreadsheet, and I know exactly where they are. Find them like that. But not so for these older tubes. They're still waiting for their turn to get checked and sorted. I went through all my tubes. I don't have a huge number of this vintage of tube, and guess what? I do not have the replacement I might require. So that was disappointing also. So let's repeat the test. Maybe I'll discover that I was misled last night. And I was thinking a bit more about what prompted me to do this long shot here, and I think it was the effect of rushing. Yesterday things dragged on when I was replacing these. I chopped almost half an hour out of that video. If you watched it, it's a half an hour of me fiddling around with these two capacitors. They're just stupid things going wrong while I'm trying to install them. They clipped all that out. But by the time I got around to the end of what you saw in that video, a lot of time had gone by, and I was worn out. And plus I knew it was lunch. Speed up, try to go quick. don't put anything new on the critical path. I got no time for that. And the result is, I jump to conclusions. This wire being an example. As it typically happens with doing this kind of work, and I'm sure all kinds of work, hey, this is easy to do. It turns out not to be quite so easy. I had to make this hole bigger. I had to look around for, yeah. So I got to the point where I was kind of wound up, anxious to get done. I really want to get the alignment done on this radio. I want to get it done. I have more radios to work on. So shame on me letting all those effects come home to roost. Okay, so let's repeat this signal tracing. Can we find the hum? The challenge in doing this is that at times I have to have the volume up on the radio and the speaker is producing the sound along with my signal tracer over here, which is hard to determine just who exactly is making the sound. So we'll have to just, how that sounds on video, I don't know. Okay, here we go, watching the dim bulbs. Just one sec. Jumped right in here. Should be careful. Yeah. There we go. I saw the light come on just a little wee bit. That's fine. And you're listening to my signal tracer making those pops. This guy has a low hum in it. Okay, now there's a new hum in the room coming from here. They sound so similar. There's the radio operating. Let me repeat the finger test. Okay, and again, this is in an isolation transformer. More than just this. There's another one behind it. And I'm standing on rubber. I can't believe it. I have brand new slippers today. Look at that. Got them yesterday in the mail. Yeah, brand new slippers. So here we go. Nothing. Something. So that's a little odd. The radio's turned right down. Which I should really check the schematic, but I'm pretty sure. Well, maybe not. This terminal is grounded right here on the volume control. So with the volume turned down, you're grounding out this side. And that would be a good reason why my finger doesn't produce a sound. Well, how about produce a sound? The other side, it kind of should be the same thing, shouldn't it? But it's not. Now that's not very loud. Let me put a little resistance in. .009. Is it that much different than .01? No. So, even though this is a little odd, I'm just going to attribute it to the fact that it's very high impedance from this side up, and the small impedance in here at, of course, it's 60 cycles, a little low frequency. That's not 60 anyway. That's, I'm not sure what that is. I'm babbling already. It's just something I ought to be aware of. Okay, let us do some signal tracing here. I'm doing this with audio. So the volume down. Now, I gotta turn the volume up on my tracer quite high here. Did you notice the cabinets here? The owner brought the cabinet over. There we go. So, I don't hear much there. Mostly the hum you hear is from this guy himself. Other side. Volume up. Now, it's hard for you to tell, but it's coming out of both speakers, what we're hearing. I don't think it's there. We'll go around. This is the grid connection. I don't think it's there. Volume up a bit. The fact that the volume for the radio comes through that little blue capacitor suggests to me there's really no problem there. Anyway, we want to look. We've looked at the grid here. Let's look at the plate of this tube. You can see the capacitor that connects the plate to the grid of the output tube right here. Here we go. There's a big voltage there. What do we hear? Here. There's going to be a pop when I do this. Here. Here. Now, yes, the signal's way down at the grid. It's much lower. But I hear nothing in terms of a hum there. Or a weird sound. Ay, ay, ay. You know, I don't hear much hum out of this at all. Wait a minute. Yeah, you know, it's just so endemic here in my shop, this kind of sound, that I'm not recognizing it. For sure, there's that crummy sound coming out of there. Does not seem to vary with the volume control. So, that suggests that this tube is responsible for the hum. Here, I can hear it pretty much clearer when I turn the radio this way. This is a, let's just double check now. Just take a peek here at the schematic and make sure I'm not full of it. 6Q7. A 6Q7. So what can you, so I don't have any 6Q7s. I have just about everything else in numbers except the 6Q7. But I did find a reference to a substitute tube of an unusual sort here. Let's see if it's in here. 6Q7. 6Q7. This is a tube substitution handbook. 6Q7. 6Q7. Here's a 6Q7, 6Q7G, GT, 6Q7, MG. MG. Okay, 6Q7, 6T7G. Didn't notice that. I looked at a different list. 6B6. There's an asterisk after the 6T7. Parallel filament circuits. Right, and that's what don't put this in series, so it must take a different current from this 6Q7. 6B6. I'm going to have to look for that. 6T7. And this is basically the same thing. Does not include what I found on a list on the Just Radios website. Just Radios is a small operation here in Canada. Mom and pop operation, sells capacitors and other things that you need, like this, some of the yellow capacitors that you see me use. I buy from them. They're just located an hour's drive from here. Not that I drive there, I don't drive there. So on there they have a list, something that's a little bit obscure for this type of tube. Now, if you're not Canadian, you may have never seen these. Even if you work on radios, you've never seen one of these. These are Canadian-made tubes made by a company called Rogers. Rogers has been a very successful company for a long, long time. Back at this time, they were building radios, Rogers radio and the famous Rogers Majestic radio, with a Rogers brand on it. And they were a forward-thinking experimental type company, and they came up with this. These are spray shielded tubes. This is a metal sprayed on shield. You can actually see a little metal tang coming out here. That I'm sure goes down to one of the pins. And so this is the attempt to get away from sliding a big metal cover over top of a tube, which this one appears to require but isn't there. Could that be the problem? They haven't investigated that possibility too well yet. So, but these tubes kind of in a world of their own. Rogers built radios specifically for these tubes. That's a 6K7. Yeah, there's a 6K7 in this radio. But it doesn't look like that. Wow, I think maybe I just revealed something here. Is this a 6K7? Let me just depart for a moment here. It is, I think. Let me just look right at the tube diagram. Yeah, this is a 6K7. Maybe I should use the Rogers 6K7. Of course, this doesn't have a pin connection to ground like this would provide. So it would take a little bit of rewiring. That's interesting. Never thought about that. 6B7 M. Label is often written right up on the top of the glass here or along the body. 6J8. I'm not going to go through these, just looking at them for fun. 6F5M. So there's apparently a tube called a 78M, something like this, made by Rogers. I think it's a 78, don't quote me on that, it's a number, 78 something. If I had one of those, apparently that's a replacement for this guy. And then I could replace the tube and discover if the hum is really coming from the tube. Can't do that, couldn't find any, dead ends everywhere last night. So that's what happened off camera. Here I am facing this hummy radio. So I think I'm going to pop the grid off of here and see what difference it makes. I'm just going to turn the radio off while I do that. How hot are you? Not hot yet. Or another way, I should really put a ground on here. Let's see what this does though. I can do the ground thing next. Ooh, that's much louder, isn't it? Oh! What happened there? What did happen there? Yeah, I discovered how sensitive this is. Is it this tube? Okay, let's put a ground on it. What if I just touch this? This is being done with no volume, of course. It doesn't matter that you need. This is past the volume control. Jackpot! What happened there? That was unexpected. Totally unexpected. It broke into oscillation and was able to sustain its oscillation. A little loud on the volume here. Let's stick a good ground on there. Better ground it back to the minus point. I think this is only proving that that tube is in trouble. Now, I haven't removed any of these tubes from the radio. I've never pulled them out, stuck them back in. Haven't in any way refreshed the tube pin contact. Maybe that's what the problem is. So I'm going to put this on ground, on the B minus. Make sure this clip lead doesn't come off. There we go. That's good and solid. I can't really clip this on here. And I got. Give me a second here. I'm going to look for something I can use. Just 1 second. Okay, couldn't find what I was after. We're just going to put this on. Like so. Okay, we're going to go power on. Never had this set on full power here yet. It's probably running around 100 volts. 109. Going to drop a bit. Let's hope it doesn't go into that squealy sound. Okay, there we go. 100 volts. That's okay. This may be loud. It's pretty darn quiet. That would suggest to me that somehow the heater is affecting the grid of this tube. It would have to be affecting the cathode too, wouldn't it? I think another tube's got to go in there to get rid of this. Somewhere I have more of those Rogers tubes. I could not hunt them down last night, so I'm going to spend a little time looking for more Rogers coated tubes. Oh, the thing about these tubes, this is the predecessor to the metal tube. The metal tube followed this, and then these were laid away. This is an earlier style of tube anyway, out of the late 30s, early 40s. Interesting history to tube development, of course. Okay, I'm going to go hunt for some more possible replacement here. Good luck to me. Well, maybe luck is on my side. Take a look at this. The first thing I did was go to this old radio I have out in my garage. This is a radio I took a couple of shots at fixing, a couple of days on it, and decided, no, not going to happen. That was quite a while ago, but I've retained the radio. It's just been sitting in my garage. Chassis loose. I pulled it out. I looked down, and this tube says 75M on it. See, these are Rogers tubes all through here. Look for the who made this. Licensed by Canadian Radio Patents. I can't read that tiny print. Let's get a little help here. A little help from my friend. Who made this radio? There it is down. DeForest Crosley Limited, Toronto. Now we got to be a little careful. Look at Rogers Majestic. These companies were buying rights from each other. They were buying each other. They were buying names from each other, doing stuff like that. So Rogers Majestic Corporation, DeForest Crosley Limited. Type 81. Yeah, I gave up on this guy because the wires underneath are absolutely stiff. It looked to me like somebody else had been in there monkeying around. So anyway, here we go. Let's get this out of here. There we go. Oh boy, boy, now is that a good tube or is that not a good tube? Should we really stick it in there or should we not? What about the ground terminal on it? Can you just pop it in, or just set this aside? Oh, this is a very heavy reader. It's a huge transformer and it weighs a ton. Weighs way more than it looks like it should weigh. 75 M. Oh, 75? 78? Okay, I'm going to get that list up. We're going to take a look at it. Okay, so this is from the Just Radios website, and they focus on selling capacitors, resistors, and stuff like that. I'm not promoting them. I have no relationship with this group except occasional emails when I'm buying stuff from them. I'm just another customer like anybody else. But they have some interesting information on their website, including this. Rogers Type M radio tube substitution information, which apparently is very scarce. And you can go on the website, you can read this, has some interesting information on it, but we just want to look at this table. We want to find over here 6Q7. What did they get rid of it? Here it is. 6Q7 75M. And that is what this tube is. I'm looking at it again. You know, it says 75M 6B6. That's that other number that was quoted in the substitution guide. 6B6. Gee, I wonder if I have any 6B6s. Let's just take a look at my tube stock here for a moment, and we'll see. I have a 6B6. 6B right here. Not even in my list. 6B7, Rogers coded. Only one of them. Okay, well, I have one option here, one opportunity. It's definitely a challenge trying to stock and store tubes because of lots of reasons I won't go into. So I have a system that I developed over years, which is working out quite well. Basically, I leave the radio in the garage, and when I need a tube, I bring the radio in and pull the tube out. No, that's not what I do. Okay. We should test this. I have a couple options. The easiest way to test it is plug it right in and see what happens. That doesn't sound like a good idea because the shield here is connected to a pin. Almost certainly this pin lines up with the little thing. I've never really toyed around with one of these. Well, let's toy around a little bit. Find out some stuff. How metallized is that? Is that metal right on the surface? Sprayed on metal? Can I just read its resistance here? Not so easy. What about up at the top here? It looks a little different. Setting. Make sure it's working. Pretty much touch them together there. Oh, no, I'm getting some readings with them separate. There's probably a bit of a patina on this. What about this black area? Looks painted to me. It looks like they painted over it. So that would make some sense. Put your hand on it. I don't think we're going to get anything there. So let's guess on this pin. See if I can get anything up here. Yeah. Oh, that's my finger. Oh, that's okay. Look at that. Well, I guess that's kind of proving that this... Well, let's check some other pins. See if we can disprove it. What happened? That's the one that I got the... What happened? There it goes. Just must be some sweet spots on this surface. Okay, right down to 0. Other pin, nearby. No, you've got to bet that that's what's going on. So we can count that pin. That's pin number. Ooh, okay. Looking at the tube from underneath, that's pin number 1. That typically is a ground pin on a lot of tubes. Now, on the 6Q7, a regular, everyday run-of-the-mill, go down to the store and buy it, 6Q7. Pin number 1 is just open. Ain't nothing going on there. So if we look in the radio now, and we look at the tube in question, and we look at pin number 1. I'm going to pull this out before we make a mistake, Jim. So there's a pin in there, but nothing is attached to the terminal. The terminal is open. You can see it in the camera from that distance. So it's all set up. Did I do that right now? No, I didn't do it right. Did I do it right? I'm just lining this up with the pin, with the key. That's right. It is right. Yeah, so I can just take this and connect it to, I guess it would go to the B- connection. Is that true now? Or, for instance, the shield that's missing on this tube is connected to the chassis. You know, when I'm helping somebody else with another radio through email, and I'm getting some of that into my head here while I'm looking at this. How is the that's right, there's multiple chassis grounds. So yeah, so these cans are both grounded, by the way. I saw something on the schematic, one of them had a box around, the other one didn't. No idea why. They're both just solidly right into the chassis. Capacitor is solidly into the chassis. Well, that's odd. Oh, that is odd. Where's my other camera? Let's take a look at the oddness here. So what I'm reacting to is how the capacitor frame, we get any focus happening here? Hello, any focus from you? Except for close, okay. A little too close. Excuse me 1 second, just bear with me while I have to call up the dialog box to control the focus on that camera. Let's stick it about here. Okay. So I'm wondering, the question is, so what did they do with the capacitor frame? From up here, it looks pretty solid against the chassis. Oh. There's a grommet there. So there's a rubber grommet in the hole that's holding the capacitor. Or is that what that is? Because over here, there's nothing. Excuse me. But look, something was there. Now, those scratch marks could be from a tool, a tool going around there. By the way, look at how close that string is. Yay. So a lot of radios, the tuning capacitor is not, especially one with a separate There's no separate negative bus in this radio. I got two radios in my head at once. I probably got more than two in my head at the same time here. Is that significant? Is that a problem? Why the rubber grommet here? Or is that screw there? The one beside it. What's this rubber grommeted thing? Where'd the other one go? There it is up there. Oh, so this one here, that's down hard. That's the can. That's the can here. The other one is definitely the capacitor. The brass washer. Isn't that they only wanted one ground point in the capacitor frame? Is there anything else grounding the capacitor? Well, this is a little interesting because this side has a wide piece on it. I guess it gives a lot of stability to the capacitor. You screw it down hard onto the chassis and it's not going to move. This one, it's just a little stick. Couldn't provide a lot of mechanical support. Well, I'm going to go with the idea that this is the way it's supposed to be. Chances of somebody taking this off and doing this and is really, really remote. I think what they've done is they just want one ground point. That's it. And these scratch marks are just that, tool scratch marks. From the day they put this together. Can't say I've ever seen one quite like that. I mean, sometimes you do want to just have one single grounding point, so you don't have two grounding points, and then there's current flowing, even in a chassis like this, current flowing between them, and you get a potential difference. Maybe that's what that's about. It just doesn't ring well with my head, but. Okay, back to the issue then. Do we connect it to the negative or to the chassis? Well, we can start with the chassis because that's where this shield would go. Do we even have to worry about the shield? They didn't bother shielding this. Pictures I saw did not show a shield on this tube. Picture's not a guarantee. Can we just pop it in there? Let's see if this Rogers tube shows up in my RCA book. This is a, look up 6B6. Let's see what we find. 6B6. Twin diode, high mu triode. It's the same elements inside the tube. Cap up there. 6B6 versus a 6Q7. Some books have a table at the back with the pinouts in them. So you just have to look at the index number. 6Q, not SQ. SQ came after Q. In the QR 6Q7, here we are. So we've got, for instance, 2 and 7 are heaters, 3 is plate. 3 is, well, this is identical. 3 is plate, 4 and 5 are the 2, 4 and 5 are the 2. Diodes, well, it's exactly the same. What about what it says about it? Glass octal type used as a combined detector amplifier in the AVC tube. Outline 38. In the outline section. What? Okay, I won't worry about that. Tube requires octal socket, heater volt 6.3, amps 0.3, within its triode, maximum plate voltage rating 250 volts. This type is similar electrically to the 6SQ7, and curves under that type apply to the 6B6. This is a discontinued type of tube. I say stick it right in there. Let's see what happens. Ooh, no, we're not going to. Let's stick it in a tube tester first. Why not? Why not make this more complicated? Okay, no reason to stop the video here. I'm just going to flip over here. All news to me about these tubes, and very good. 6B6. Oh, cat at the door. 6B6. 6B4. 6B8. 6B6. B missing. Okay, I'm coming. I'm coming, my friendly cat. Let's give him his daily, his cameo. Introducing Peanut, my cat. What's up, buddy? Did you want to go outside? Hey, don't get distracted. You want to go outside? I see, he said, out. He speaks English. My cat speaks English. I have to let him out, and then we'll deal with the tube. Right? Right? Peanut? Okay, well, as it turns out, my cat did not want to go outside. He wanted to go on my lap. He lay down on the couch and fell asleep, so it's been quite a while since I've been in here. Last thing I remember was no 6B6. Oh yeah? 6B6 is in the augmented list here. 6B6. Here we go. So we're going to set this guy up. 6.3 volts. Signal level 1. 20L on the bias. 07300. 07300. 0610. In case you're wondering why the lighting is so weird here, it's the only way I can get this to come on the camera so you can see the meter at the same time. Sensitivity 39 is the cheater control. F. 720, put on the grid cap. 720 on here is about where my finger is pointing now. Okay. Let's see if this tube is good. Grid cap. That one. It's heating right up. Looks good so far. Give it a moment. Okay, now we're going to check for leaks. Right at the pointer. In this tube tester, the pointer normally comes up on, not on setting 1, where it is now, but on 2, 3, and 4. It's usually up a little bit. So that's fine. That looks normal. All looks normal. 720. Here we go. She's a winner. Okay. Now what I'm going to do is I'm going to pull the tube out that's in there, and we're going to do the same test on it. Fantastic. I got one. I got a tube. Very same test. Okay, let me just pull the tube out here. You know what? I'm going to do before I plug it in there, what are the chances that the settings are slightly different? Probably not at all, but let's take a look. 6Q7 here. Q7, I didn't do the diodes, did I? But that's okay. 6.3, 1, 20, 23L, slightly different here. Not identical then. Oh, wait a minute, this is totally different. 2, 7. Oh my gosh, these are completely different settings here. Definitely 6Q7. What's going wrong? Q7. Totally different settings. How does that work? Why can't I just drop it in with these settings? The second row is the same. First row is 2, 7. Can't even see it myself. It's too dark. 2, 7, 3, 0, 0. Oh, maybe it's because it does not have a attachment to the ground pin. The only one that's different is this first one. 2, 7, 3, 2, 7, 3. That's the only one that's different. 30 on the sensitivity. Gain may be a little different in this too, or the GM may be a little different. F780 grid cap. Okay, we're ready now. It's time to use the smaller grid cap. I guess I'd encountered that grid cap size problem too in the radio. Now this one, I think I need to do that. I think it might have a leak in it, so we're going to find out here. Here we go. Doesn't show any leak at all. Okay, testing the tube. That's it's stronger than the other one. What am I supposed to do now? Swap them and see what happens in the radio. I think so. We're going to put in the other tube and see what we get out of this radio. There's very little reason to be nervous about it, I think. Grid cap. Yeah. Okay. Can I just stick it on there for now? Probably not. That's not the easiest little problem to solve. Okay. I have to find my spare grid caps here. Okay, managed to find my spare grid caps with my other tube tester, and one of them is a big one, not this one, this one here. And I need to make the connection to the, how good does this have to be? Why so stiff? That's strangely stiff. I think this might be steel. Like this. Okay, that's pretty crummy, but that might do. Stick a little clip onto that. I'm going to do that. Okay, I've also clipped a very long wire onto the shield terminal for the tube. So the tube shield is connected, grounded, chassis. It's chassis. Okay. No idea what's going to happen here. That's kind of normal. I expect the radio to work. That's what I expect. Oh, not going to work until I plug it in. That's for sure. Okay, normal dim bulb response. Of course. Volume's down to start. So this long ground might act more like an antenna. This might make the situation worse. I hear something. Okay, turn it up. Well, here we are. It works. But I'd say that sound is there still. Another possibility is the heater is somehow conveying a signal into the tube accidentally. There's a signal in the heater string that shouldn't be there. It usually is drained out with capacitors or something like that. I don't think this is proving that the other tube is bad. I think the opposite is happening here. Let's see what I can try. I'm going to take this ground off and see what happens. Of course, this is past the volume control. Let's do it with power off. What happens if you leave the Rogers coating floating? Floating coating. It would sound the same to me. Now that's so quiet, I'm not sure you're even hearing it. I'm going to try to make a mental registration of the level of that sound. Mentally registered. Now I'm going to take the tube out. I don't want to pull on the glass. If I can avoid that. Don't know how rare these tubes are. They're probably not terribly rare because the demand is probably very low for the Rogers tubes. They're fairly common around here. Okay, where'd my other tube go? Here it is. Now, apparently I learned a long time ago from a stereo salesman that your sound memory is very short. 7 seconds is what he said. So if you're comparing things, and 7 seconds goes by, the comparison is probably false at that point. It's been a lot more than 7 seconds. Here we go. I would say it sounds exactly the same. Again, I'm not sure you can hear that. What happened to the nice radio sound? So that clicking noise is a form of interference that I often hear in my shop. I don't know where it comes from. It's going to go like that for a period of time, and then at some point it will stop, but when it stops, it doesn't just disappear. The click rate slows down and disappears. Very odd, like a motor spinning down is what I would guess it is. But it's not my furnace fan. I don't know what it is. So, what's that prove now? That proves we're chasing ghosts here with this tube, I think. The hum is from somewhere else. Well, let's consider the heater circuit. I don't think I've really stared at it too closely on the schematic. Let's take a look and see if it's got capacitors on it or not. you've got capacitors. Oh, what am I talking about? There's no, again, I'm thinking of the wrong radio. I should never work on two different radios at the same time. So I'm working on another radio just via email with someone who's asking me questions and having me look at their schematic and stuff like that. So there really isn't much chance. Here's the filaments. Now let's just look through them. Did anybody get anything hooked up to it? That doesn't count. No. 100K resistor across this one. No, it's not quite across it. It's a ground on the grid. That's related to the operation of the local oscillator. That's pretty early on in the set. Didn't I pop the grid cap off and still hear the hum? Off this tube. Let's just do that again. Let's just do that one more time. Okay, sets off. Yeah, I did this and it wasn't, if anything, the sound was louder. This is what got me to put a shielded wire there. This experiment with the open grid. So this is very similar to this. This is my probe for my signal tracer, and inside here is a tube, and the grid is connected via a wire just to this. So this is non right now, but so I'm touching this. I'm touching the grid of the tube that's inside here. That's why this thing is so big. It's not to give you the strength to really poke at it. That's not what it's for. Well, there we are. That's major noisy. And then I did this ground thing. Let me do it again. Why is it jumping around there as I shake the radio? Oh, completely silent. It seems to me it's like an inherent problem in this radio, a designed-in problem. It's quite possible that back in the day, the things that we can hear coming out of this radio now, hums and that, they just weren't in existence. And there's computers in here. My computer screen produces a fair bit of noise. That could easily be what's upsetting the whole situation. The radio is sensitive there, and it just happens to be in a pool full of noise signals. And no matter what I do, I'm not going to beat it out of the radio. Wait a minute now. Now there is a huge resistor here, 10 megohms. And that's intended to bleed down any charge that's building up, any DC charge that's building up on the grid. Because after all, the grid is inside of a glass envelope full of electrons under pressure. And some of them are bound to strike the grid. Just like you put your hand out your car window, sooner or later you're going to get a bug in your hand. That's kind of what's happening with the grid. So they put a big resistor there because it's not much of a charge to bleed off. And with the big resistor, you maintain sensitivity, extremely high sensitivity. What if I drop this from the 10 megohms and drop it to a 1 megohm sized resistor? 1/10 as big. There's a bit of a voltage divider with the with the volume control. I'm thinking too hard. Let's just do that. I'm just going to parallel in maybe instead of a 10 megohm, maybe a 5. Maybe we'll cut it in half. Now put a 5 in parallel with it, and then we'll end up with what, 3 or 2 or something like that, and see what that does. I gotta find one now. Okay, so I've got a 5 megohm resistor here. want to bridge it in there kind of temporarily. Am I going to need to solder this? Looks like it. And just tack it on. Okay, I'm going to tack that resistor in place there, and then we'll give it a test. Okay, ready for the experiment here. Let me just make sure I didn't short this out. The resistor's just barely tacked in there, but that's going to work. So I've got a 5 in parallel with a 10. Do the math, it's going to come out to 3 or something like that. So that's quite a drop from 10 down to 3. That's quite a good drop. Let me just turn off my soldering iron. The soldering iron I'm using now doesn't produce much electrical noise, but the last soldering iron I was using in here emitted quite a bit of noise just sitting there operating. So okay, we're ready. Let's plug it in. It's off. Now, a lot longer than 7 seconds went by. There is the hum. I'll just pop that resistor off at some point. We'll see what happens here. Appears as if the volume is weaker. So my guess is it did do something. Now let me pop it off with a piece of plastic here. If I can pop it off. Difference whatsoever. That's a little hard to believe. It's very hard to believe. Didn't make any difference. Oh, it does a little bit. Now we need a smaller resistor. We need a smaller resistor than this one. Oh, I got it on there pretty good. Okay, let's try something crazy. Something really small. A 1 meg resistor. That'll drop it down to like a 900K or something like that. Okay, 1 meg resistor. Okay, got that little guy soldered in there, only one leg, and the other one I'll be able to move like a switch. That's my plan. There we go. Should be connected right now, but it's just touching, so I don't know. Here it comes. Okay. Okay, I'll use that. Off. On. Barking up the wrong tree here. Well, I don't know what else I can do about this situation. Now, does this radio use the chassis as part of the heater circuit? I think yes, it does. And we should see that. We pick a tube and look at the heater connections and see if one of them drops right down to the chassis. Here's one here. There's the lug. A rivet, rather. And yes, the rivet. Well, this could be the problem. The rivet is coming up onto here. It's probably done the same with each one of these tubes. Probably has the same arrangement. Just very hard to spot. Where one side of the heater is just taken right to the chassis. And there's a single heater supply wire in here. So all the heater current flowing in the chassis. You'd kind of think that putting a shield here would eliminate any of that. So there's no AVC involved with this tube. There's no way for an AVC hum to kind of get in there if there were such a thing. And you know, I could short it out right here and completely short it out and see what happens. Any reason to be afraid to do that just with a clip lead? Always a reason to be afraid to do that just with a clip lead. Let me just peek at the schematic here briefly. Not really, no. There's really no reason to be too afraid here. The clip lead is itself an antenna. You know what? I'm going to pull that little resistor out of there. I'm going to wear the tubes out on this radio. I've chased around hums before I couldn't find, and one of them I remember turned into a bad rivet in a similar situation maybe to this. I should be able to flex the rivet and get some kind of action, but how do you flex a you know, these tube sockets? That's a toughie. Okay, we're going to put it on. It's easier to take it off than it is to put it on, so we'll put it on now. Okay, power on. And what happened when I took the cap off this and tapped it and the thing just went into wild oscillations? What was that all about? That oscillation that we heard when the cap was off, that could have actually been caused by vibrations of the radio itself from the speaker. The speaker may have shaken the radio enough to transmit a mechanical vibration into the tube and set up a feedback, basic simple feedback. Could it do it electrically? They're not that far apart. Well, I hear the hum. I don't hear the radio anymore. What is it about the cathode? The cathode goes right to ground here, and the ground is dependent on the rivet technique. Now, is that true with this tube? So I'm looking in there, and I don't see such a rivet. And just because I don't see it doesn't mean it isn't there. It's pretty hard. Let's look with the close-up camera. I'm going to shut this off so I don't get myself into trouble. And we'll switch to the close-up camera here. So what we're looking for is from that rivet a piece coming up. It's hard to believe there is one. And the other rivets just in the open. If you look at this tube, you can clearly see there's a ring around the rivet. And there's a ring around that rivet. Where did it? No, they just snuck it up there so tight you can't see it. Let's bring on a little more light here. Am I looking at the right tube now? No, I've switched tubes. Switch tubes. Okay, this one. You know, it looks like it might be underneath that wire. Underneath that yellow wire. We just kind of bent it up to the on the side of this terminal and soldered it up so much you can't see it. If we look at this one, well, that's my monkey business, resoldering it. That's kind of what's happened there. Let's look at these other tube sockets here. There's the rivet with the ring, and again you can't really see. Oh, yes you can. Sticking right up. This one's handled a little differently. So this is the tube that's supposed to have a shield on it. It's only handled differently in the sense that it's not bent over and soldered right up. They've used a piece of wire coming out. Okay, let's go look at this one. There it is there. There it is swinging over and getting soldered. What do they do? Now this would be different. This is the rectifier tube there. I don't think they're going to do anything like that here. How is this tube? There's the rivets for the tube socket, but I just don't think it is handled the same way at all, because the heater is part of the B voltage circuit. Well, I would have to flex the tube socket and see if in fact that rivet has become high resistance. Is there some, what if I spray it with something? How would that help? I've got to get in there and kind of wedge up the wedge things up a bit. Notice it's right next to the heater, that high wattage resistors, kind of aimed right at it. Well, let's give that a try. I'll try to work that connection and see if stuff happens. How am I going to do that? I need a tool I can apply a fair bit of force with. At the same time, won't get me into trouble. Okay, I shouldn't be doing this without actually doing it. This guy is just a little too big. How about this one here? Well, I can put some force on it anyway. Okay, we'll leave this on. Power up. This will be very subtle. I wouldn't expect this to be much of an effect. Would it be better for me to disconnect the grid, let the grid float, and then hunt for it? Good question. I'm not going to do that. Okay, I'm hearing it. Do you think this is metal all the way through? Hard to say offhand. Let's find out. It'd be good to know. You can use those tools at one end easily in your hand. And you could do that without really realizing you wouldn't realize it at first, but you'd eventually realize it, that's for sure. Here, just sit there. I hit a sweet spot here to make this work. Okay. Go one up here. Or was my hand on it when I did that? Or I already did the test. How convincing is this? Pretty convincing. Two separate pieces of metal. Okay, that's question is done. Feels as solid as can be, of course. Careful now, I'm right in there among all these wires. So I try improving the connection, improve the connection to ground. So this is on the chassis here. That's making a difference. That's interesting. That made a difference. Is that true on all these terminals? Let's pick another one. This one here. Well, this one is... Well, this is a main one here because this is really dependent. Coming from that filter capacitor through here, and then it's dependent on this rivet. I hear no difference. Let's try another one. So this one is one down here. No. That's definitely making a difference. It's very subtle. I don't know if you can hear that at all. I mean, I can't what am I doing to the radio itself? Nothing, of course. So just listening to the hum. Well, I got a long clip lead here. What if I do it with a really short little piece of wire? Well, I'm going to solder in a new connection to ground. Where can I go for that? Where can I go and get a ground? Right there, right close to it. What else is on the ground? Didn't I determine... No, we don't want... We need to go right onto the chassis. Otherwise, I'm just attaching to another poorly grounded point. Right onto the chassis. And the only thing that's really... Well, there's another connection here to the chassis that's mechanical only. This one. Right here. That would be a bad actor. Turn back on. We'll get a grip on that. thing just turned. Well, you can see how loose it is on the... So that's just riveted. So there's a screw over here that I thought was screwing it down with a lock washer, but that's what's holding the speaker down. The two of them. This is the rivet. Ooh, careful there. This is the rivet. The rivet of nonsense. Yeah, exactly. Could it be another tube that's introducing the hum? Didn't I already kind of... No, it really can't be. It's really all about this tube. How if I pull that tube right out and run the set? Pull it, yeah, that'll get rid of it. Just tell my buddy, or you got one tube too many in your set. Why am I doing it with pliers? It's a little warm now. Not really. Not really. Get them right out of there. Okay, so the set's not likely to work well. Only reason I can do this is because there's a transformer with a 6-volt output, not a series tubes. And I would be really shocked if it still hums. Let's see. Well, I don't hear anything. That's the problem. The problem is having that tube in there. Yeah, of course, nothing at all. What would happen if I hooked up the grid here to the grid of this tube? Well, let's see. There's the grid of the output tube. Let me just take a peek at the schematic here. The grid of the output tube is well, it's got a half million ohm resistor, and then it's biased in that trick way. If I use a capacitor, I can bypass. Well, it's stupid because with this tube out, there's no diodes in the detector anymore. So what would I prove with that? And it would prove that crazy experiments can be done. That would be interesting. Let's do that. Crazy experiment here. It's one of those things where after you do it, you go, oh, now I see. This great big honking capacitor. Pick the grid off of here. So this one right here. Sure we're not shorting. Okay. And we're gonna live. This is just craziness. This could be very loud. Who knows what might come out of this? Okay, preparing for a short duration power up. Here we go. Pretty quiet. Did I actually turn it on? I heard the tubes tingle. Volume up. Not enough oomph to do anything. That's a crazy experiment anyway. Okay, shut her down because it doesn't lead to I don't know where it would lead. Okay, nothing bad happened though. That's good. I think this radio's got a hum in it, and like it or not, that's the situation. And I'm going to accept that that's the way it is. I'm going to carry on and do the alignment work on it. The only last thing is that this tube's not shielded. Hey, I wonder if that has a Rogers tube replacement with the shield. Of course, then I have to hook up the shield. I think we've done enough here. We're going to end up doing some damage to the radio just from monkeying around. It's not my radio. Conclusion is there's a little bit of a noise with it. Now, obviously, if you're listening to a strong station, you're not going to hear any of that anyway. And maybe that was the truth of it all along. So I think today is over too, because it's noon again. Yes, I did sleep through part of today's effort, but I think tomorrow I'm just going to go ahead and do the alignment on the radio, and hey, maybe that will drum the hum out of it. Kind of doubt that. So thanks a lot for watching. I hope you find this stuff interesting, and you have some curiosity too, similar to me, about what's going on, and enjoy seeing me try to figure it out and fail. No, I've reached a conclusion here. The conclusion is this radio has a buzzy hum in it, period. That's my conclusion. Thanks a lot for watching. See you tomorrow.